डॉक्टर बाबासाहेब आंबेडकर ओपन युनिव्हर्सिटी.
Namaskar Mitro. In the last session of the subject operating system and software installation, we have seen the learning objectives, we have seen introduction, we have seen what is operating system, we have seen different types of operating system, as well as we have seen evolution of operating system. Today in this video session, we are going to learn the most popular operating system, we are going to learn the market share of different operating systems, we are going to learn the functions that is to be performed by operating system, and finally we will learn the concepts of operating system. So let us start the session with the most popular operating systems. This is the list of most popular operating systems in the current world. One is the Windows, second is the Mac OS, and the third one is the Linux. Microsoft Windows is a family of operating systems for personal and business computers. Windows dominates the personal computer world. It offers a graphical user interface, virtual memory management, multitasking, and it supports many peripheral devices. And most of the users uses Windows operating system. Windows have different varieties of it. It means it has started from Windows NT, then Windows XP, Windows Vista, Windows 7, Windows 8, 8.1, and now in the market Windows 10 is available. Next is Mac. Mac OS is the official name of the Apple Macintosh operating system. Mac OS features a graphical user interface that utilizes Windows icons, and all applications that run on Macintosh computer have a similar user interface. Normally Apple users, MacBook Pro users have this Mac OS. Next is Linux. Linux is different from Windows as well as Mac OS. Linux is free as well as open source, whereas Windows and Mac is not at all free. You have to pay charge for it. Whereas Linux is free and open source. Free means you do not have to pay anything for it, and open source means you can write your own code, you can modify the kernel of the operating system, you can build your own operating system for the Linux and you can use it. So Linux is a freely distributed open source operating system that runs on a number of hardware platforms. So this is the market share of different operating system. This shows the figure shows the market share during 2017. You can see the half of the market share has been taken by Windows 7. Then 25% of market share has been taken by Windows 10. So overall, if you see, Microsoft Windows has taken 80% of the market share. Very few percent of market share has been taken by Linux as well as Mac OS and other operating systems. So let us learn which are the main functions of operating system. Mainly operating system, as I told you, the main task of operating system is to provide the bridge between a user and the computer hardware. In addition to that, operating system manages resources. Resources means the computer hardware resources, which means the processor, the memory, the file system, as well as the devices. So let us learn how operating system manages memory. Memory means the main memory. You can consider it as your RAM. Main memory, another name of main memory is RAM. The main memory is very limited, it is very short, and each and every process, each and every application that wants to run on your computer system needs to be stored in the memory. Once it gets stored in main memory, then and then its program will start running. Now every application needs memory and we have limited amount of memory. So it may happen that every process may not get memory when they want. It is the task of operating system to manage this memory for the processes. So memory management refers to the management of primary memory or main memory. It is a large array of words or bytes where each word has its own address. Main memory provides a fast storage that can be accessed directly by the CPU. For a program to be executed, as I said earlier, it must in the main memory. An operating system does the following activities for memory management. The first, it keeps track of primary memory, what part of primary memory is in use and what part is free. The free part can be allocated to the next processes in future. In multiprogramming, the OS decides which process gets memory when and how much. It allocates the memory when a process requests it to do so. It deallocates the memory when the process gets completed or the interruption to the process arrives. So this is all about what operating system does for memory management. Next is processor management. If we talk about single processor system, it means it is a single processor and multiple processes wants to use this processor. Now in this case, it is the task of operating system to decide which process will get the processor. Processor is nothing but the CPU. So in multiprogramming environment, the OS decides which process gets the processor when and for how much time. This function is called process scheduling. An operating system does the following activities for processor management. First, it keeps track of processor and status of the process. The program responsible for this task is called traffic controller. It allocates the processor to the process. It deallocates the processor from the process. So this is what the operating system does for processor management. Next, device management. A computer system gets connected to various devices, and normally these devices are called input-output devices, and it is the task of operating system to manage these input-output devices for the user, for the processes, for the applications. An operating system manages device communication via their respective drivers. You might be knowing that for each and every input-output devices, drivers are available. You must install these drivers along with operating system. Nowadays, the operating systems have inbuilt drivers in them. So when you install the operating systems, automatically drivers will also be installed. But sometimes if your driver gets corrupted, for example, the driver for sound gets corrupted, you may not listen the sound from your system. In that case, you have to find a driver for your system, you have to install it, then and then you will be able to listen the sound. So for every input-output device, drivers are available. It is the task of operating system to make it possible for the user. It does the following activities for device management. It keeps track of all devices. Program responsible for this task is known as I/O controller. It decides which process gets the device when and for how much time. It allocates the device to the process. It deallocates the device from the process. So these are all the tasks which operating system does for device management. Finally, next resource is file management. A file system is normally organized into directories for easy navigation and usage. These directories may contain files and other directories. Here you can say directories are nothing but the folders which you know. ફોલ્ડર હોય, ફોલ્ડરની અંદર ફાઇલ પણ હોય, ફોલ્ડરની અંદર બીજું ફોલ્ડર પણ હોય, જે તમે તમારી નોર્મલ ડે ટુ ડે યુઝમાં ઓપરેટિંગ સિસ્ટમમાં તમારા ડેસ્કટોપ ઉપર યુઝ કરો છો એ. An operating system does the following activities for file management. It keeps track of the information, location, uses, status of your file. જો તમે તમારી કોઈ એક ડ્રાઈવ ઓપન કરો, એમાં ફોલ્ડર ઓપન કરો અને એ ફોલ્ડર ઓપન કર્યા પછી તમને એ ફોલ્ડરની અંદરની દરેક ફાઇલનું એક લિસ્ટ બતાવશે. એ લિસ્ટમાં તમને ફાઇલનું નામ બતાવશે, એનું લોકેશન બતાવેલું હોય, એ લાસ્ટ ક્યારે અપડેટ થઈ હતી એ પણ બતાવ્યું હોય, એ ફાઇલનો ટાઈપ બતાવે, એ ફાઇલ કોણ કોણ એક્સેસ કરી શકે એ પણ બતાવે. સો ઓલ ધીઝ આર ટાસ્ક ઓફ ઓપરેટિંગ સિસ્ટમ વિથ રિસ્પેક્ટ ટુ ફાઇલ મેનેજમેન્ટ. લેટ અસ ગો અહેડ. Next very much important task for the operating system is to provide a user interface. User interface is the main feature provided by all operating systems. It provides way in which users interact with application programs and computer hardware. Almost all operating systems today provide graphical user interface. Before many years, there was command line interface, which was very difficult to use by the normal user. You have to write code, you have to write commands for getting the operations done. Whereas nowadays GUIs are available, you can click on the icon, by using mouse and keyboard you can perform all your tasks. Next is running applications. To run any application, the operating system must allocate the computer resources like memory or IO devices, as we have seen in the last few slides. For example, to run applications like word processor and spreadsheets, the operating system should allocate the application programs and must load that application program into main memory, which we normally called as RAM. Next, operating system should provide support for built-in utility programs. The operating system uses these utility programs for maintenance and repairs. Utility programs help identify problems, locate the lost files, repair the corrupted files, the damaged files, and it also take backup of the data. Next task the operating system manages is the control of the computer hardware. The operating system lies between the programs, the application programs and basic input-output interface. The BIOS manages the hardware very efficiently. All programs that need hardware resources to run applications must go through this operating system, and the operating system can either access the hardware through BIOS or the device drivers. Next, we are going to learn other functions which are going to be performed by operating system, which operating system performs. The first is security. By means of password and similar other techniques, it prevents unauthorized access to program and data. You can lock your folders, you can lock your files so that other people, unprivileged access to your files, to your data can be restricted. તમે તમારી ફાઇલને તમે તમારા ફોલ્ડર્સને પાસવર્ડ પ્રોટેક્ટ કરી શકો જેથી બીજો કોઈ યુઝર એને એક્સેસ કરી શકે નહીં, and that task is provided by operating system. That facility is provided by operating system. Control over performance. It records a delay between the request for a service and response from the system. It also performs job accounting. It keeps track of time and resources used by various jobs and users. It also detects errors, production of dumps, traces, error messages and other debugging or error detecting aids. કેટલીક વખત તમે જો વિન્ડોઝ યુઝ કરતા હો અને સિસ્ટમમાં કોઈ એરર આવે તો તમને ઓટોમેટિકલી વિન્ડોઝ એક મેસેજ આપશે દેટ સિસ્ટમમાં આ એરર આવી છે, do you want to perform troubleshoot or else do you want to send a mail to the Microsoft. So that is nothing but error detecting facility, the error detecting aids. Next, it also coordinates softwares and users. The coordination and assignment of compilers, interpreters, assemblers and other software to the various users of computer systems. So these are all the tasks of operating system, the functions performed by operating system. Now let us learn the concepts of operating system. The first concept is multitasking. Multitasking is the ability to execute more than one task or programs at the same time. The terms multitasking and multiprocessing are often used interchangeably, although multiprocessing means that more than one processes are involved. In multitasking, only one processor or CPU is there, and only one process can access that CPU, but that access management, that scheduling is so efficient that user will not know that he is the only person or other users are also there to use the processor. So in multitasking only one processor is involved, but it moves from one program or one task to another task so fast that it gives the appearance to the user that executing all of the programs at the same time. There are two basic types of multitasking. One is called preemptive and second is called non-preemptive. In preemptive type of multitasking, if one process is running on the CPU, operating system may snatch CPU from it, may take CPU from it and may give that CPU to the other process. Preemptive માં operating system કોઈ એક પ્રોસેસ પાસેથી પ્રોસેસર કે મેમરી લઈને બીજી પ્રોસેસને આપી શકે. whereas in case of non preemptive operating system આવું કરી શકે નહીં. એક પ્રોસેસને કોઈ રિસોર્સ આપેલો હોય તો જ્યાં સુધી એ રિસોર્સ એ પ્રોસેસ છોડે નહીં ત્યાં સુધી ઓપરેટિંગ સિસ્ટમ બીજી કોઈ પ્રોસેસને એ રિસોર્સ આપી શકે નહીં. That is called non-preemptive. So in preemptive multitasking, the operating system provides CPU time slots to each program, and as time slot expires, it switches to the another program. OS2, Windows 95, Windows NT, and almost all operating systems uses this preemptive multitasking. In cooperative or non-preemptive multitasking technique, each program gets control the CPU for as long as it finishes the execution. એટલે પ્રોસેસ જ્યાં સુધી ફિનિશ ના કરે પોતાનું એક્ઝિક્યુશન, પ્રોસેસ જ્યાં સુધી CPU છોડે નહીં ત્યાં સુધી એ CPU એ પ્રોસેસની જોડે જ રહે. એ છોડે પછી જ ઓપરેટિંગ સિસ્ટમ એને બીજી કોઈ પ્રોસેસને અસાઇન કરી શકે. So by this figure you can easily understand the preemptive and non-preemptive multitasking. This is the preemptive multitasking where the resource has been used by one process, the process is using the resource and at some point of time it has been given to the other process. Now that other process is using the resource, at some point of time it has been switched to the process 1. That is preemptive. And in case of non-preemptive, one process is using it and some interrupt comes, when process leaves it to the other process, then and then it will be given to the process 2. So that is preemptive and non-preemptive multitasking. Next is multi-user. When referring to the computer operating system, a multi-user term implies that operating system which supports multiple users at once or different times. Time sharing systems are multi-user systems. In order to utilize processor's idle time during I/O operation, most batch processing systems for mainframe computers are implemented as multi-users. However, the term multitasking is more common in this context. So this is the example of multi-user, that one resource is there and that resource is going to be used by multiple users at the same time. For example, in a Unix operating system, multiple remote users have access to the Unix shell prompt at the same time. As I have explained here, you can assume that this is Unix shell prompt that will be used by multiple users at the same time. Thin client concept also can be implemented by using multiple X Windows sessions spread across multiple terminals powered by a single machine. Similar functions were also available under MP, mcurrent, concurrent DOS, as well as multi-user DOS, Flex OS, etc. Next is the process. This is the main part of the operating system. For every application the user uses, behind the curtain there is a process. That process performs the task for the application. If you have seen Control Alt Delete, if you press Control Alt Delete, the task manager will be opened, and in that task manager you can see the number of opened applications, the number of running applications, as well as the processes which runs them. An operating system executes varieties of programs. In batch systems it is called jobs, and in time set systems it is called task or user programs. Process is nothing but a program in execution. Process execution must progress in the sequential fashion. This is the diagram of the memory. Normally this memory is divided in 4 parts. As you can see here, the one part is text part, that is nothing but your compiled program. That is, you can simply say a program. Then the next part is the data part. The data which is going to be used in your program, that data will be stored in data part. Normally the local data will be stored in data part. Next is the heap part and stack part. The text and data parts are static, whereas heap and stack parts are dynamic. The size of heap and stack can change. Heap grows here, according to the figure, heap grows upwards and stack grows downwards. Normally this heap is used to store dynamic data, and stack is normally used to store the functions, function calling and function returning, such kind of things will be stored in stack, whereas heap stores the dynamic data of your program. So this is how the memory is divided into 4 parts. So this is what I have explained, what stack contains and what heap contains. A process can be in any of these 2 states. If we consider 2-state process model, then process can be in 2 states. One is either running or non-running. The state running means the process has occupied the processor and it is running its task. Non-running process means the process is waiting for the CPU, process is currently not using the processor. Next, in 5 or 6 states, the process can be in any of these states. If we go to the more advanced states for the process, then process can be in any of these 5 states. At the start, when the process gets created, it will be in the new state. When the process gets stored in the main memory, it will become the ready state. So whenever you start the application, it will be in the new state for the temporary time duration. When that process or when that application gets memory, it will transit from this new state to ready state. So your main memory contains all processes which are ready for the execution, which needs the processor. When your scheduler dispatches the process, it means when the process which is there inside the memory gets the processor, the state of the process will be changed from ready state to the running state. And as I said, if my process is in running state, it means it is currently using the CPU. When some interrupt comes, the process has to leave the processor and process will come from running state to ready state. Sometimes process has to wait for IO operation. So in that case, process will go from running state to the waiting state, and once the IO operation gets completed, the process will go from waiting state to the ready state. Once the process gets completed, it will exit and it will go to the terminated state. So let us look at what each and every state says. New means the process is in the stage of being created. Ready means the process has all the resources available that it needed to run, but the CPU is not currently available. Running means the CPU is working on this process instruction. Waiting means the process can't run at the moment because it is waiting for some resources to become available or for some event to occur. For example, the process may be waiting for the keyboard input or disk access request or inter-process messages, a timer to go off or a child process to finish. When the process is in terminated state, it means the process has completed. So this is the process state diagram. Next, the process queues. So as you can see, whenever the process gets created and whenever the process gets memory, it will be stored into the ready queue. So this ready queue contains all those processes which have all the resources available except the CPU. It means all the processes are in main memory and all these processes needs CPU. Whenever any process gets dispatched, it will be given to the processor and it will come from ready state to the running state. From that, whenever some timeout occurs, the process will be the processor will be snatched from the process and it will be at the end of ready queue. Whenever some event occurs, let us say event 1 or event 2 or event 3, so there will be a separate queue for each and every event, and the process which is waiting for event 1 to get occurred will be stored at the end of this queue. Similarly, the process which is waiting for event 2 to get occur will be stored at the end of event 2 queue. When event 1 gets completed, one of the process from that event will be stored at the back of the ready queue. Next is process control block. To control the process, there is a process control block. For each process, there is a process control block, which normally we say PCB, which stores the following things. It stores the state of the process. As I said, it can be either running, it can be finished, it can be waiting. Every state will be stored in the process state. Next is process ID. Each and every process has process ID in the operating system. That process ID will be there in the process control block. It also contains CPU registers and program counters. This needs to be saved and restored when swapping of the process in and out of the CPU. CPU scheduling information such as priority information and pointers to the scheduling queue. What is the priority of this process? So that operating system can schedule more priority process first and less priority process afterwards. Next is memory management information, accounting information, IO status information. All these informations will be stored in process control block. So this is what process control block is: process state, process number, program counter, registers, memory limits, list of open files for this process get stored in this block. So this is what happens when CPU switches from one process to another process. Concentrate on the figure. Here at this point of time, process P0 is executing, and when interrupt comes, the PCB of it will be saved and PCB of other process, let us say process 1, will be restored, and process 1 will get the CPU and it will start execution. At some point of time, at this time, some interrupt comes and PCB of process 1 will be saved and PCB of process 0 will be restored, and process 0 will get the CPU. So this switching will be performed by what part of the operating system? It will be done by the scheduler. That is what we are going to learn: context switch and schedulers. When CPU switches from one process to another process, the system must save the state of the old process and reload the saved state of another process. That we have seen in the last figure. Context switch time is overhead because during this time CPU is not performing any productive work. CPU is not being utilized. Long-term schedulers and short-term schedulers, these are two different schedulers. The long-term scheduler selects which processes should be brought into the ready queue. It means when the process gets created, then which processes should be stored in the memory. That decision will be taken by long-term schedulers, whereas short-term schedulers decides from main memory which processes will get the CPU. That is the task of short-term scheduler. The short-term scheduler is invoked very frequently, mostly in milliseconds, whereas long-term schedulers is invoked very infrequently, mostly in seconds or minutes. The long-term scheduler controls the degree of multiprogramming, because multiprogramming means the number of processes which are residing in main memory. That is called the degree of multiprogramming, and that is handled by long-term schedulers. The processes can be of two types. One is IO bound and CPU bound. The IO bound processes performs most of the task. It requires most of the time IO, and it requires CPU very short amount of time, whereas CPU bound processes requires processor CPU for most of the time, and for very short duration it requires IO. It is the task of long-term scheduler to select mix of these processes for residing in the main memory. If all processes are IO bound, then ready queue will be empty, and if all processes are CPU bound, then IO queue will be empty. Devices will be unused. So it is the duty of long-term scheduler to select the mix of these processes. Next is process creation. What happens when the process gets created? Parent process create child processes, which in turn create other processes, forming a tree of process. Resource sharing: parent and children may share all of the resources. children may share few subset of the parents' resources, or parent and children may not share any of the resources. In terms of execution wise, parent and children may execute concurrently, or else parent may wait until the children terminates. Next, process termination. Process executes last statement and asks the operating system to decide it to exit. Process may return the output of data to the parent, that is called wait. Process resources are deallocated when the process gets terminated. Parent may terminate execution of child process, that is called abort. And child has, when this parent will abort the child, when child has exceeded the allocated resources, or else the task assigned to child is no longer required, or else the parent is exiting. Next is cooperating processes and independent process. Cooperating processes are those processes which requires to share the information amongst them, to pass the information between two processes. Then two processes are called cooperating processes. Independent process can't affect or be affected by the execution of other process, whereas cooperating processes can affect or be affected by the execution of another process. And next is interprocess communication. It is the mechanism for processes to communicate and to synchronize their actions. Two basic communication models are there. One is called shared memory model, second is message passing model. In case of shared memory model, the memory is shared between two processes. One process will put its data in the memory and other process will get the data. In case of message passing model, two processes will send and receive messages to each other. Next is thread. Threads are very popular way to improve the CPU's performance through parallelism. A thread is a single sequence of stream or unit of concurrency within a process. A lightweight process is nothing but a thread. Processes are used to group resources together, and threads are the entities scheduled for the execution on the CPU. Threads are also called, as I said, lightweight processes, as they own some of the properties of the processes. Like a process, a thread consists of a program counter, a register, a stack, as shown in this figure. You can see this is a single threaded model. This is the PCB, the user address space, user stack and kernel stack. If this is one process and this process has created the threads, process control block and user address space will be shared amongst these threads, whereas thread control block, user stack and kernel stack will be available to each of the threads. Which are the benefits of the thread? It takes less time to create a new thread than a process. It takes less time to terminate a thread than a process. It takes less time to switch between two threads within the same process. Since threads within the same process share memory and files, they can communicate with each other very easily. So this is all about operating system concepts. In this session, we have learned functions performed by operating system, most popular operating systems, market share of operating systems, and different concepts of operating systems. Thank you.